This is example 12.1 from the book. We went over it in class on Friday. It's on page 562. So the first thing you're going to do, we're going to calculate the rate law for this problem. And you're given this equation up here. It's written a little funny with two lines. But the first thing to do is to write the rate law using just the reactants. So the general formula for the rate law is rate equals K, which is a constant. We'll learn how to solve for that next class period. And then you take the first reactant, this guy, and you're going to do the concentration, and then you're going to do that to a certain power. And the book likes to use letters M, N, and then if there's a third one, P. And I'm going to go in alphabetical order. So I'm going to call the first one to the mth power, and then the second one BR to the nth power. And you could use any letter, that doesn't really matter. And then the last one, H to the P power. And what we are going to solve for in this problem right now is these letters. We're going to solve for those letters using our experimental data. So I'm going to go ahead and start solving for the first one. So if I want to solve for BrO3, I'm going to look at the different reactions, and I'm going to choose an experiment where BrO3 changed. So if I look at experiment 1 and 2, BrO3 changed in those reactions. So I'm going to do experiment 2, and then I'm going to divide it by data from experiment 1. And the first thing I'm going to do is the rate on this side. So I'm going to take the rate from experiment 2, 1.6 times 10 to the negative third, and I'm going to divide it by 8.0 times 10 to the negative fourth. And I'm going to set that equal to, this gets kind of long, the rate of BrO3, and I'm going to put that on the bottom here. And then times the rate of just BR times the rate of just concentration. I just said rate, I meant concentration. And then I'm going to divide that by all the data from the experiment 1. So it'll be 0.1, 0.1, and 0.1. So these are the initial concentrations. And then you're going to divide if, and oops, I forgot. This is to the M, this is to the N, and this is to the P. And if they're the same on the top and the bottom, then they can cancel out. So those guys cancel out and those guys cancel out. And then over here, when we divide, we get 2 over on this side. And then when we simplify this, we also get 2. So we have 2 to the mth power. Therefore, m is 1. All right, we're going to walk through and do that for BR and then for H. And we'll find all of the rates, and then we can plug them into here. So this guy is 1. That's what we already know. So for BR, we want to find 2 experiments where just BR changed. So if we look at experiments 2 and 3, you'll see just BR changed on those. So I'm going to go ahead and set up the problem and solve. Doing experiment 3 on the top this time and dividing it by experiment 2. First, I write the rate of each of those. So 3.2 times 10 to the negative third divided by 1.6 times 10 to the negative third. Those are measured initial rates. And then I'm going to set this up to their concentrations. And I'm going to go in the same order I did in the first one. So M, N, and P. Okay, when you set this up, you'll see this and this cancel out, this and this cancel out, and we're going to be left with a 2 on this side, and we're going to be left with 2 to the n here. Just like the first one, its n is to the first. So this is going to be a 1 as well. Lastly, we're going to solve for P. Let me go ahead and get a fresh paper out for that. To solve for H, I'm going to use the rate in experiment 4, and I'm going to be dividing it by the rate in experiment 1. So 3.2 times 10 to the third goes on top, and 8.0 times 10 to the negative fourth goes on the bottom. By the way, the units for rate is meters per second, sorry, molarity per second, and then the unit for all your molarities is just a big M. Okay, so now I'm going to plug in the other information, rate 4 on the top, rate 1 on the bottom. So when everything's set up, you see that the M and the N cancel out, and this time when we divide this, we get 4, or 0.0 on this side, and we divide these guys, we get 2. So you have to think a little bit more. You're trying to figure out how can we get P, how can we solve for P here, and you find out that P is 2. The last thing to do is to write the rate with these values that we found. So our first guy is into the first order. Our second one is to the first order. And our last one, H plus, is to the second order. Very last thing you can do is you can add up these subscripts, and you would say this reaction is in the fourth order. Fourth order just means it happens faster than something of a lower order.